Okay, it's time for the Unit 7, beginning of Unit 7. It's about accuracy and precision of measurements. Okay, some of you have never probably had this before. It's not too terribly difficult, but it's new. It might be a little weird at start. Okay, here's the first. There's two sections to this assignment. For each measurement, you're going to find two things. You got to find the degree of precision, and the range of the measurement. Okay, so find the degree of precision and the range of the measurement. So here's example 1. We have 3.6 inches. Here's how you find the degree of the precision. Okay, you put your decimal point down, and whatever the last digit is, okay, you're going to put a 1 in for that. It's like you're replacing the 6 with a 1. The last digit you replace with a 1. Everything before that you turn to 0. Okay, and that's it for part A, 0.1. Now here's how you find the range. You take that 3.6 and you're going to put a plus minus sign. You're going to add and subtract. Now what are you going to add and subtract? You're not going to add or subtract the 0.1. You have to divide the degree of precision by 2. Okay, this is the answer for A. Okay, now you're going to always divide that by 2. So 0.05. Now you're going to subtract it first. So 3.6 minus 0.05 is 3.55. So that's the low for the range. Put a dash, and then you add 3.65. So that measurement can be between here and here. Okay, that's how you write the answer. 3.55 to 3.65. Example 2. 4.3 centimeters. Okay, so A, put the decimal down. The last digit you replace with 1. Everything before it becomes 0. So that's it, same as it was last time. Then you take the 4.3, you add and subtract at the same time. So you're going to divide that by 2, and it's going to be 0.05 again. Then first I minus, I get 4.25. And then I plus, and that's going to be 4.35. Okay, example 3. We have 15.885 inches. Okay, so decimal. The last digit is replaced with 1. Everything before it, 0, 0, 0. Before the decimal, you only need 1 0. Okay. So that's a degree of precision. Now you're going to divide that by. Now you're going to take your 15.885 and you're going to minus and add. Okay. Actually, do plus minus. That makes more sense. Then not that number. You got to divide that number by 2. 0.0005. 5 10,000ths. Okay, so then first you minus. I get 15.8845. And then I go back here and add. $15.8855. Okay, and that's the range. Example 4. 12.002 inches. So A Remember, the last digit becomes a 1, then you have 2 zeros before that, and then you put a 0 in front. 1,000th. 1,000th of an inch is your degree of precision. Now you take your 12.002, add and subtract, and we divide that guy right there by 2. Okay, 0.0005. Okay, so first we minus 12.0015. And then the next one's going to be 12.0025. Okay. Example 5. .01 mm. Okay, so A and B. Now, I guess you don't have to replace it. It's already a 1. You put the 0 in front. 0. Remember, always switch the very last digit to a 1. Anything before turns to 0. Okay, then we take our 7.01, add and subtract. We got to divide that by 2, and that's 0.005. So if I minus 7.01 minus 0.005, I get 7.005. And then when I add, it's 7.015, I think. Yeah, it's 15. Okay, example 6. 9.1 mm. So point, and then that 1 will stay a 1. Anything before it goes to 0. Okay. So that's the answer for part A. Part B, you take your 9.1, you plus and minus, and then divide that by 2. So 0.05. So first I minus, it's 9.05. And then I add, it's 9.15. Okay, and that's how you find the degree of precision and then the range of the measurement. Okay, now the next part is not very much work, but it can be a little confusing. I did my best to type in some rules for you on this document. And it says determine the number of significant digits. They're called sigfigs. It's just an abbreviation for significant digits. Sigfigs in the following measurements. Okay, so example 7. We have 2.0378. Now, that's 5 digits, but which ones are significant? Well, here's the rules. All non-zeros are significant. So anything that's not a 0, I'm going to mark that's significant. Okay? Zeros sitting between 2 non-zero digits are significant. So now we're at the zeros. The non-zeros are easy to mark. Okay? Zeros sitting between 2 non-zero digits are significant. So that zero's between 2 non-zeros, so it's significant as well. So that's all the digits, so all 5 of them are significant. The answer is 5. Okay? Example 8. Don't just determine, you want to watch all these examples. Just trust me. Okay? So 1, 2, 3, 4. Now, what about that 0 there? Well, I can't use the between the non-zeros because it's not between them. Okay, so keep reading. Leading zeros before a decimal are not significant, but that's not leading in front of the decimal, so that rule doesn't apply. End zeros when you have a decimal are significant. This includes those before the decimal. Now that's an end zero and there's a decimal, okay? So that's significant. So again, we have 5. So if you see a decimal, the end zeros are significant. Okay, here I need to change something on the document. Again, the end zeros, there's 2 rules. There's if you have a decimal, they're significant. Now, if you have no decimal, the end zeros are not significant. Okay, we'll see that as we move on here. Okay. All right, 9709.3. So you mark all the non-zero, and that's between zeros sitting between 2 non-zeros are significant. So that's again 5. Okay, the answer is not just how many there are. That's why you got to keep watching, okay? 12.090. 1, 2, 3. Zeros between 2 non-zeros are significant, so that's significant. Now how about that one? Let's keep reading. End zeros when you have a decimal are significant. End zeros when you have no decimal are not. Well, we have a decimal, so that's significant. So again, it's 5. Okay, example 11. This one's going to be a little different. Okay, mark the non-zeros, so that's 3. Zeros sitting between non-zeros are significant. Now those zeros are not between the non-zeros, so we can't use that rule. Leading zeros before a decimal are not significant. Well, those do not lead off, okay? Those are not leading zeros. They'd be over here if they were, okay? So that rule doesn't apply. Those are end zeros, okay? Now, if you have a decimal, those are significant. If you have no decimal, they're not significant. Well, we don't have a decimal, so those aren't significant, okay? So that's 3. Basically, you mark them when it's between, and then the end zeros, if they're leading or end, that's what you have to analyze, okay? Example 12. Okay, so we got those 2. The zeros I have are not between, okay, so I can't, they're leading, okay? Leading zeros before a decimal are not significant, so all of these leading zeros need to go, okay? So we just have 2. Okay, pretty sure that's right. Again, leading zeros are never going to be significant, so just know that. End zeros, it depends if you have a decimal or not. 13. If they're leading, you cross them out in any case, okay? If they're at the end, you have to decide if there's a decimal there or not. Okay, the next one we have 4353.0. So I know we got these 4. That 0 is not a between, so is it at the beginning or is it at the end? It's at the end. So is it does it have a decimal or is there not? Yeah, you have a decimal, okay? So you count it, and that's 5. 0.0370. We got these. We don't have any zeros between. Okay, we have zeros at the beginning. Those are never significant. The 0 at the end is only significant if there's a decimal, and there is a decimal, so guess what? We're marking it, okay? So that's 3. Make sure I'm explaining this right because I left my 0.0370. Yeah, so 3. Okay, example 15. 66.080. So we have these 3 for sure. That's between, so that counts. Now that's an end 0. Do you have a decimal? Yes, you do, so that counts. Okay, so that's 5. So these two, that's a between. That's an end 0 and there's a decimal, so yep, you count it. Okay, so 4. I'm going to type up 2 more examples, just make sure I get all my bases covered here. Okay, just a second, sorry about this. Kind of winging it here. I mean, I haven't made any mistakes so far, but okay, yep, I got it. I think I got it. Okay, example 17. Okay, well that counts. These zeros are at the end. They're end zeros. Do you have a decimal? Yes, you do, so you count them all. Okay? So that's going to be 7. Okay? Again, end zeros count if there's a decimal. And I put, this includes those before the decimal. Okay? And the last one, we got 45. And then 5 zeros. We count these. We don't have any between zeros. You have end zeros, but do you have a decimal? End zeros, when you have no decimal, are not significant. Okay, so you just have 2 in that problem. So follow those rules. Let me know if you got a question. Shoot me.